All right, dart gun problem. First thing we do on all these problems is establish where your zero line is. Zero line is where C is. That's where our heights will be measured. And we know whenever the object is on the zero line, the height is zero, and therefore your potential energy is zero. I also know at point C they gave me the speed, so I can figure out the kinetic energy, 1/2 mv squared. But before I put the numbers in, I notice that my mass is in grams. I want to change to kilograms by dividing by 1,000. Then I can plug my numbers in. It's 1/2 times the kilograms, 0.05, times 12 meters per second squared, comes out to 3.6 joules. Once I know the PE and the KE in one of the locations, I can add them together to find the total energy, which is called the mechanical energy. Mechanical energy is PE plus KE. It's 3.6 joules, and that is the same everywhere along the path. That's what the law of conservation of energy says, that total energy has to stay the same even though it changes forms from one to another. Next, up at the very top, I know the speed at the top of the parabola is 0, and that means the kinetic energy has to be 0 at the top. So if my total energy is 3.6 and the KE is 0, that means all of that energy has to be potential energy. Once I know the potential energy formula, I can use the PE formula to find the height by dividing by mg. So 3.6 divided by 0.05 divided by 10, I got 7.2 meters for the height. Next, I see that they gave me the initial height of the gun at point A is 2.5 meters. If I know the height, I can calculate the PE doing mgh. So my mass, 0.05 times 10 for gravity times 2.5 meters, gives me 1.2 joules. I mentioned the other day that the gravitational potential energy is the same on both sides here because these are both talking about position A. At position A, we're holding the gun a particular height, and we have squeezed the spring storing energy in it, and that stored energy turns into kinetic energy of the dart when it leaves. So I know the total energy and I know the PE, so I'm going to subtract the PE from the total energy, and that tells me what's left over for the kinetic energy is 2.4 joules. And that also tells me that the energy stored in the spring had to be 2.4 joules, because that energy turns into the KE. Last, we can figure out the velocity if I know the kinetic energy. We use the KE formula to solve for V. So 2 times KE over m with the square root gives me 9.7 meters per second. So here's my final answers. And I could also go one step farther. I know I'm storing energy by squeezing the spring. If I tell you the spring constant, 250 newtons per meter, we can figure out how far I squeeze the spring. That's called the displacement. Using the elastic potential energy formula, that's 1/2 kx squared. Solving that formula for x, we get 2 times the elastic potential energy divided by k. The square root would tell me what the displacement is. All right, this paper goes in your practice section behind your practice page. And speaking of practice page, let's get it out. We have a practice problem to do next.